Given your answer to question 2, what is the molarity of bromate in reaction mixture 2? At the beginning of the reaction, you are using 0.04 molar potassium bromate. Again, you can use that M1V1, so 0.04 molar M1 volume. Now we are referring to reaction mixture 2. So you have to refer to your table in your experiment procedure, reaction mixture 2. What is the amount of potassium bromate we are using? So we can refer to that, and if you look up the table, there would be again 10 milliliters of potassium bromate you are using. Okay, so potassium bromate in the reaction mixture 2 you are using, let me show you that. Reaction mixture 2, potassium bromate, do you see that it is 2? So the reaction mixture 2, potassium bromate, 10 milliliters. Okay, that's the amount you, so this is the table you're going to refer to. Okay, so 0.04, so 10 milliliters of potassium bromate. Want to find out the M2 total volume is 50 milliliters. So when you do this calculation, you will get M2 as 0.008, 0.0080. Okay, concentration. Express your answer to two significant figures. So if you do it in exponential notation, that would be 8.0 E3, right? That's how you find the concentration. And then the next question, given your answer to question 2, what is the molarity of H plus in the reaction mixture 4? Now you have to refer to the reaction mixture 4 and see what is the volume of HCl you're going to be using for that. And we are given the M1.01 molar HCl. Refer to the table and see what is the volume of HCl in the reaction mixture 4, and then you will find that it is 20 milliliters. Please make sure to check if the numbers that I'm putting is correct. Okay, that's your responsibility. M2 we don't know, and again the total volume is 50. So with this calculation you can find out what is the M2 going to be. Okay, so I'm going to leave it for you to find out. I'm just showing you how to do the calculation. So find out the M2. And question number 6. In each reaction mixture, you will be using 10 milliliters, 0.001 molar sodium thiosulfate. Okay, and it is asking how many moles of thiosulfate are present at the beginning of each reaction. Remember, for each reaction mixture, we are using 10 milliliters of sodium thiosulfate. That's a constant amount. And then the molarity is given. So what's the number of moles? So the number of moles, you can find out molarity times the volume. So the molarity is 0.0010 moles over volume, and you use 10 milliliters and you need to convert it to liters. So this will give you the number of moles. So do this calculation and write down the number. You can also express in exponential notation. Okay, question number 6. So you can do that. I'll just show you how to do the calculation. Get the answer and write down. And you can express in up to 2 significant figures. Okay, just like I have written down over here 8.0, so you can express in 2 significant figures. So question number 7. Suppose that it takes about 40 seconds for the reaction mixture to turn blue for reaction mixture 3. What is the relative rate of this reaction? So the relative rate equation is 1000 over time. Okay, so you take the number 1000 and then you're gonna divide it by the time it takes for the reaction mixture to turn blue. So it takes 40 seconds. So 1000 you divide by 40. What number you're gonna get? It's easy calculation, so you can do that. So 1000 over 40, that's going to be the relative rate of the reaction. Okay, and question 8. rate law for the reaction you will be studying in this experiment has the form rate, K is the rate constant. Instead of M, N and P as we have in our handout or our textbook, here we have X, Y, Z. Okay. Suppose you compare the relative rate of reaction mixture 3 to the relative rate of reaction mixture 1. Which exponent in the rate law can be determined from this comparison? Reaction mixture 3 to the relative of rate of reaction mixture 1. So rate 3 and rate 1. So if you do rate 3, we are going to compare it with rate 1. What you're going to do is you're going to divide the two terms. And then when you do divide, if it happen to be the same volume, their concentrations are going to be the same, so they're going to be cancelled. So let's say, you know, the rate constants are going to be the same. If we do not do at two different temperatures, so at the same temperature, rate constants are the same. So the first one, I minus X BRO3 minus, that's going to be your Y, and H plus going to be Z. And then for the rate 1 also we have I minus BRO3 X Y H plus Z. Now you have to go back to your concentrations, or we can also do by the volume, because if it is the same volume, the concentration is going to be the same amount, since we have all of the reaction mixtures 50 milliliters. So rate 3 and rate 1. So if you refer to rate 3 and rate 1, go ahead and check that table. So you will see I minus for rate 1 and rate 3. I going to be the same amount, because it's going to be using 10 milliliters each time. So I going to be the same. So they're going to be using 10 milliliters and 10 milliliters. Okay. So then these two terms going to get cancelled. And for the bromate, for the reaction rate 3 and 1 in your table, you're going to be using 20 milliliters bromate and 10 milliliters bromate. And for the hydrochloric acid also, it's going to be 10 milliliters, 10 milliliters. Okay. So let me take you to the table and explain you what does that mean. Over here, you see reaction mixture 3 and 1. If you look at those, 1 and 3. Potassium iodide, 10, 10. And then potassium bromate, 10 and 20. Hydrochloric acid, 10 and 10. So with these volumes, when you convert it to concentration in the 50 milliliter sample, they're going to be the same. Whereas for the bromate is going to be 10 and 20. So that's going to be different. Correct? So because of that, you can see when you do divide rate 3 by rate 1, so the terms iodide and H plus, they are going to be the same, so they will cancel. Okay, and then the rate constant K also going to cancel. So when you compare the reaction mixture 3 to reaction mixture 1, which exponent can be determined from this comparison? That's going to be then Y, because these two are going to be the different one. So we can find out the exponent Y by dividing the two rate equations. Okay, so the answer going to be Y. And then determine the exponent mentioned in question 8 to the nearest integer, assuming that it took 75 seconds for the reaction to turn blue in reaction mixture 1 and 40 seconds for it to turn blue in reaction mixture 3. So 75 seconds reaction mixture 1, and then the 40 seconds for the reaction mixture 3. So you're going to find out the value for the exponent, meaning we are going to find out the y. So we can use this equation right here. So the rate 3, it says 40 seconds for it to turn blue in reaction mixture 3. So we can do divide reaction rate 3 by reaction rate 1. So rate 3 is going to be, remember it's the rate of the reaction is going to be 1000 over 40. Okay, equals, and now you see everything cancels except bromate. That's going to be your y in reaction mixture 3, and you divide by concentration of bromate, that's also y. Okay, and then you're going to divide this by 1000 over 75. So 1000 and 1000 can get cancelled. So we have 75 over 40. Okay, so that will be 75 over 40. And then the concentration of bromate in reaction mixture 3. What is the concentration of bromate ion in reaction mixture 3? Have we calculated that before? Maybe we can quickly do that calculation. So if you want to find out what is the concentration of bromate ion in reaction mixture 3. So please do that calculation using M1V1 equals M2V2, and then you will find that concentration to be 0.016. Okay, 0.016 y over, and then in the reaction mixture 1, so this is the reaction mixture 3 and this is 1, you will find the concentration of bromate is going to be 0.008. Okay, I hope you know how to calculate. Remember, it's going to be M1V1 equals M2V2, and M1 going to be the concentration of bromate for the let's say if it is for the reaction mixture 1, concentration is 0.04, and then the volume you took was 10, don't know M2, and the volume was 50 milliliters. So this will give you the concentration of potassium bromate in reaction mixture 1. Okay, and then the reaction mixture 3, again you use 0.04 molar, and for the third one you use 20 milliliters. Okay, so M2 and then 50 milliliters. That will give you 0.008. Okay, reaction mixture 3, 008, reaction mixture 1, 0.016. So both of these is the same exponent, y. So 0.016 over 0.0028, that's going to be 2 from this side, 2 raised to the power y, and 75 over 40 is going to be 1.875. So we need to find out what is this exponent y. So how do we find out the exponent? Okay, so let me show you how to find out the exponent. Why can't you erase? Okay, good. Okay, let me show you how to do the exponent. Let's say you have a term like that. You want to find, there is this expression A equals B raised to the power m. and this is the exponent. So you want to find out the exponent, so you can use this m equals log A over log B. So similarly, we want to find out what is y. So y equals log 1.875 over log 2. Okay, so log 1.875 over log 2, log, it would be something like this, 0.273 over 0.301. You will get a number like 0.9109. So 0.9, when you round it up, is going to be very close to 1. Okay, so the value of the exponent is going to be 1. And this is the same method you're going to be using to find out the orders when you perform your virtual lab and then do the calculations also. Okay, so the value of this exponent is going to be 1. Okay, and then the question 10. Suppose the reaction rate is the same when x is 0.005 and what is going on? Okay, so suppose the reaction is the same when x is 0.005 molar and y is 0.002, as it is when x equals 0.01 and y 0.02. So y is kept constant. We didn't do anything to the y, but we change x. X is changed to 0.005 to 0.01. What happened? Reaction rate is the same. Reaction didn't change. You change the concentration of x, but reaction didn't change. So what is going to be the order of that reaction? What is the order with respect to x? If the concentration doesn't, if the rate of the reaction doesn't change when the concentration doubles, that means the reaction is zeroth order. If the reaction rate doubles, that's going to be first order. If the reaction rate quadruple, that's going to be second order reaction. Okay, all right, I think that's all the questions we have.